Okay, you guys, we're on page 30, 11.5, and let me remind you of one rule that we came up with yesterday. I was like, hey, what if we've got 5 log base 2 of x equals 29? Couple different ways we could go to solve this. What's one thing that you might do? Are we saying the go around thing? Don't we have this little nugget over here that isn't involved in the go around? Ooh, he's saying, why don't I move this guy up? So that's something that we reminded of yesterday. That little coefficient can move, bless you, to be an exponent. Then can I say base? Where the heck did I get? Oh yeah, base around the equal sign, land there. So I'd have 2 to the 29th equals to the, great. So you can only do this base around the equal sign up when it's 1 log. Can only do that then. What would you do now? Bless you. X is to the 5th power, so how would I? 5th root. Is the 5th root the same as raising it to the 1/5? It is. So you could write it either this way, or you could say, I just want to have the 5th root of 2 to the 29th. I don't care which way you write it. It's going to get us the right answer. So a couple different things. I might say that I've got 2 to the 29th, and I might say I've got that to the 1/5. Whoa. Or I might say math 4, I got, math 5. I got the 5th root of 2 to the 29th. Same answer, 55.7. That was one way to start this problem. What if you're like, I forgot about that whole exponent guy? Could I have done something differently instead of bring that 5 over there? Yeah.
I actually don't think it's right.
It's not going to hurt anybody.
Multiplying the 5 by 1/5.
You're like raising it. Multiplying the 5 by 1/5. Exactly. Is multiplying by 1/5 the same as dividing by 5? Yes. Multiplying by 1/5. Check this out. If you wrote times 1/5, those cancel out. That's the exact same thing as dividing by 5. So that's exactly what I was looking for, Avril. These cancel out. I get log base 2 of x is 29 divided by 5. 29 divided by 5. I could just write it that way or just say 5.8. Now can I do my whoopty-scoopty?
Yeah.
Could I say 2 to the 5.8 equals landing at the x? Let's go see what 2 to the 5.8 is. Oh, snap. It's still 55.7, and that's what we got over here. So, again, don't feel like your way is going to be wrong because there are multiple ways to do this, okay? Go with your gut. So, let's go take a peek. Do you notice that all of these 4 problems don't have logs in them? Do you agree that none of them have a log? Could we go put this in log form? What's my base? Yeah. So we've got a log base 6 of, go around the equal sign, equals, could I type that left side of my calculator? Yeah. What would I do to get x by itself then? Done. Log base 6 of 81. Math up arrow. Log base. Oops, I just hit the wrong buttons. Math up arrow. Log base of 6 of 81. Will you have a calculator for this entire thing? Chia, buddy. We got 0.817. Now, you might be like, did I get that right? You guys, we can just go plug it in and say, is 6 to the 3 times that answer equal to 81? So on your equation, you're going to be like this. Chia, buddy. I'm going to show another way to have done this problem in case you're like, I wouldn't have gone from there to there. Another way to do it is you agree we're allowed to move my exponents out front as long as there's a log. Do you agree there is no log here? But you guys, I can go move that 3x out front and I can put a log there. If I put a log on the left, I need to put a log on the right. You do not need to write this down. I'm going to just show you something because it's going to help on the next problem. So look what I just did. I brought my exponent out front. The only way I get to do that is if there's a log. So I put a log. Notice that there's no base on my log. Great. That base is implied to be tan. Okay. Then how would I get x by itself? Divide by 3 and? Yeah, since it's all being multiplied together, I could just divide by 3 log 6, and you are going to be blown away. These cancel, these cancel. Check this out. The answer was 0.817. If I take just, I can hit just the log button now, log of 81, divided by 3 log of 6. Huh. So, I don't think that was an easier way to do this problem, but I want to show you. Because this guy's got the variables in 2 exponents, I can't do my loop-de-swoop-de thing anymore because I got 2 bases. So here's my hint for the second one. Do you agree? I got variable in the exponent. To bring it down, we must log. So we're going to say I've got x minus 1 log of 5. So you can bring any exponent down as long as you log it. I wouldn't do a base because it's just easier to have a log with a base 10. Equals, how would I bring this x down, do you think? X log 2. And you guys, say it again. We are allowed to divide logs like we just did over here, but we've got x's on both sides. Any ideas what you want to do? Just to try to start getting x's on one side?
You gotta distribute.
I would distribute. Boom, boom. So I have x log of 5 minus,
Log of 5.
yeah, 1 log of 5 or just log of 5, says Evan. Evan, I'm glad that you're holding your pencil back to normal. So how would I get all my logs on one side? Do you want to bring x log 5 to the right side, or do you want to bring x log 2 to the left side? Yeah, let's go move this x log 5 to the right because there's an x over there. Let's get rid of the other stuff. So we got a negative log of 5 is an x log 2 minus an x log 5. Gosh.
Can we do x log -3?
Ooh. Okay. I love what you're thinking. Evan's saying, but yesterday you taught us when we're subtracting, we can combine these with division. Ev, do you agree it has to be 1 log 2 minus 1 log of 5 for that to happen? So Ev, if we did that, don't write this down, guys, I would have to move these exponents back up, and I'm kind of in the problem that we had before, because it'd be log of 2 to the x minus log of 5 to the x. So then, Evan, you're right. Don't write this down, people. We'd have 2 to the x over 5 to the x. But again, I've got a problem because that variable's still in the exponent. I don't know how to get rid of a variable in the exponent. So what I like about where we are right now is that, bless you, what I like about where we are right now, Ev, is I have no x's in exponents. You down with that?
Yeah.
Could I factor out an x on that right side? They both have an x in common. So if I factor that out, what would I have left?
Log 2 minus log 5.
Yeah. Equals a negative log 5 on the left side. What's my final answer? How am I going to do that? Divide by all that stuff. Log 2 minus log 5. Awesome, Nat. To me, this color's like eucalyptus. I'm digging it. Guys, everybody go to your calculator. Push, all that gets canceled. Let's go type in this whole left side. Ugh.
Can you cancel out the log? No.
We cannot, yeah, because we got the adding and subtracting, and it's a log of 5, so it's like one number. So let's go just do a negative log of 5. You don't have to do the log base anymore because the base is just 10. We got a log of 2 minus a log of 5. Anyone get 1.7?
Yep.
Yeah. I'm going to go 1.756 only because if you're taking AP Calc next year, every answer must have 3 decimals. So maybe if we're just starting to get in the hang of it. Guys, let's look at these 5 questions that we have left. When you have one variable in the exponent, I suggest doing this. Boop. When I've got 2 variables in the exponents, which do you agree I don't have any more 2 variables in the exponents? Like I did on that one. This one I had 2 variables in the exponent. So you guys, when we can just loop, swoop, and pull, let's do it. Loop, swoop, and pull. Here we go. Log, what's my base? 2.2 of, perfect, equals, booyah. What are we doing? Just add 5. So we're going to go type that entire left side plus 5. I do need to do log base. Math up arrow log base of 2.2, 9.32. Take all that, add 5 to it.
7.83.
Beauteous. I know some of you are like, dude, I want one rule and I want to stick to it. Could I say, I don't want to do the loop, swoop, and pull? You call it a weird name and it's not intuitive to me. You don't have to do that, you guys. Could I say, I want to bring my exponent out front? If you wanted to do that, we'd have x minus 5, log of 2.2. If I log the left, I've got a log the right. Oops, that needs to be a 9.32. We would distribute my x log of 2.2 minus 5 log of 2.2 equals log of 9.32. Whoop, 0.32. I could then add my 5 log of 2.2. I do think that this takes longer. 5 log of 2.2. And I'd have x log of 2.2 equals all of that. And then I would have to divide by log of 2.2. Oh my gosh. Let me just show you though. We do get the same answer. If I did log of 9.32 plus 5 log of 2.2 divided by my log of 2.2, we got the 7.831. So you can always just say, I'm bringing my exponent down every time. You could always do that. You don't have to. Over here, do you want to bring the x out front and say x log 4.3, or do we want to do a loop, swoop, and pull? Loop, swoop, and pull it. Here we go. Log base of equals. Can we just type that in our calculator? Cha. Cha. I only wrote this one as 2.97. Are there 3 decimals or no?
Yeah, 2.970.
Thanks. Oh, it was a 0? Thanks.
It would round to 11.
Oh, it would? 76.2. Yeah, 2.971. You right. Boop. Am I going to take off for that? No. Would AP take off for that? Yes.
Why did you want it so many?
Had nothing for you. Yep, accuracy. How about this guy?
Distribute.
Put the 4 on the exponent.
So that's a good question. I cannot distribute because this log of x plus 3, that's just one term. But I agree 4 is being multiplied by it. What'd you say?
I said put in the exponent.
Oh, we could always do that. She says, go take that 4, put it up there. Could we divide by 4? Yes. You could do 2 different things. Who's vibing divide by 4? Who's vibing put that 4 up there? Okay, I'm going to do it both ways. So if you divide it by 4, what's 9 divided by 4? 9/4. I'm great with that because who cares? It is 2.25 or 9/4. Doesn't matter. My Lorenzo or anyone else who wants to put that 4 up there, we would have log of x plus 3 to the 4th equals 9. These are my 2 different ways to do it. Okay, so this Lorenzo, I think this is what you're looking at. My people over here, what's my base? Good. When I don't give you a base, you guys, in eucalyptus, it's 10. Around the equal sign. 10 to the what? 9/4 equals. I just love it. Final answer? How about this? No calculator. Final answer. What do you think? 10 to the 9/4. And then?
Minus 3. Minus 3.
Done. Oh, really?
I don't know, I have no idea.
Oh, I got you. But you're saying 10 to the 2.25 would be over 100.
We'll see what this is.
I think it's going to be 100 something.
Well,
What'd you get, Sophie?
I think it's gonna be under 100.
Really?
I'm just gonna be over
Yes.
100.
But 10 squared is 100.
Okay, it's gonna be over 100.
Yeah.
I was thinking it was 7/4.
Oh, I got you. Yeah. Then you would be right. And then minus 3.
174.
Yes. Guys, am I fine with you leaving your answer like this? Sure. I don't care. Can you type that in your calculator? Yeah. Do I care if you can? Yeah. You've done the pre-calc of it. That's amazing. What if I was Lorenzo and I bumped that up there? Could I still do this? Could I still say 10 to the 9th is x plus 3 to the 4th? Yeah, Lorenz.
So when we don't have a base, the base is always 10.
Yes.
Okay.
Yep, that's exactly right. Yep, so we're gonna get the same exact answer. Actually, let me show you. If I was Lorenzo, I'd probably raise it to the 1/4 there. And again, this is the exact same thing as that. So we're getting the same answer. Great call, Lorenzo. When I don't give you a base, to me it's nicer because we get to just use this button. Let me show you the button. We get to just use this one as opposed to math, up arrow, log base.
Go back to the example. I didn't right now.
Sure. Guys, has anyone watched the show? You guys, let's take a peek at this guy. Do we want to take my base of 10 and loop, swoop, and pull? Ooh. Okay, I feel like everyone hesitated. Could I move that X right here? And I already have a log, so I could just say X log of 16 is 0.25. How would I get X by itself now?
Not that long.
Yes. That was the easiest route. Foshizi. That is not a new term. That is Jay-Z. I feel like circa 1992. Oh my. Is there an ability to overthink this problem?
Probably.
Is my X
It
by
really is
itself?
X right here.
Can I just type that in my calculator?
No reason not to.
Dude, I know. It is so easy to overthink. But our goal is always to get the X by itself. So when the X is by itself, just go, type it in, type it in. 3.6.
3.61.
09. Let's just do 14 together. Or do you want to do, oh no, let's do 43 together.
Together.
This one's the hardest one in my opinion.
Do it.
Let's do it.
Let's do it.
Whoo! If I've got two X's, one in each exponent, you guys, I got to log both sides. I got to take my 4X plus 3 out front. I got to. In order to do that, thank you. I just have to log it. So I'm going to say, in parentheses, are crucial. 4 plus 3X, log of 0.16. What do I have on the right side?
8 minus X. In parentheses.
Thank you, Beck.
Log 0.3.
Beautiful. Any ideas? We did one of these like it.
No, it's a distribution.
We got to distribute. So, Ev, I just want to clarify. Remember when you said distribute before? That was when I had like an X plus 3 here. You don't distribute with this, but anything out front, you can distribute to this quantity.
Yeah.
Okay. So we got 4 log of 0.16 and 3X log of 0.16. Oh my gosh, distribute on the right side too. 8 log of 0.3 minus X log of 0.3. Sheesh, get all your X's on one side. Would you rather subtract 3X or add an X? I agree, let's keep things positive. I'm gonna I'm gonna add an X log 0.3, add an X log 0.3. And subtract 4 log of 0.16 all in one step. Thank you, Nat. I don't want to have to write all this out again. Whew. Is there room for error here? Yeah.
It's the easiest way to do it.
Can you just combine them?
Wait, are you?
I can't combine anything because these logs aren't the same, but what could I factor out?
The X.
Yeah, factor out an X, y'all. X, I've got left a 3 log of 0.16 and a log of 0.3.
Yeah.
Then we just divide. That was long. Anyone get 0.343?
Yep.
That's what I got. Yeah, girl. Good job. Okay, so here's what I'm going to ask you to do. 14, 40, 42. Done.